So we'll now continue this section and we'll look at solving logarithmic equations. So again, if you're faced with a logarithmic equation that you need to solve, there are basically two directions that you can move. One is that you can change the problem to exponential form, and sometimes that makes it easier to work. The second option is to use the properties of logs that we talked about in the last section to help you solve. So let's begin with this example. Log base 3 of 4x minus 7 is equal to 2. So I'm going to go ahead and do the first option, which is changing to exponential form. So remember that you're going to start with your base. So I'll start with 3. I'm going to go to the other side of the equation and get my exponent, and then set it equal to what's left. Now, when I look at what I have, once I've changed it to exponential form, I realize that I basically just have a linear equation. 3 squared is 9. And I can easily solve this for x. So I'm going to add 7 to both sides. 9 plus 7 is going to give me 16, is equal to 4x. And then divide both sides by 4. So our answer will be x is equal to 4. So you can see in this example, by simply changing the form to exponential, the problem becomes much easier to deal with. All right, let's look at this one. 2 times log base 5 of x is equal to log base 5 of 9. So this problem seems to me like it would be a good fit for a property. It's not a good fit for changing the form because I have 2 logs, and so I really have too many pieces to try to change it to exponential form. But I can use a property. Remember that we have a property that says that numbers sitting out in the front of a log can be written as exponents. So I'm going to do that first. I'm going to take this left-hand side and I'm going to move that 2 back up and make it an exponent. Now, if you look at what's left, in order for these things to be equal, they have to be equal in every position. So they both have to have the word log, which they do. They both need to have a base of 5, which they do. And then finally, this part needs to equal this part. So let's figure out how that happens. So x squared is equal to 9. Let's figure out how that can be true. So we know that that really can be true in 2 cases. If I take the square root of both sides of this expression, I'm going to get x is equal to positive or negative 3. So it appears that I have 2 answers. However, if you attempt to evaluate a log of a negative number on your calculator, you will very quickly see that it is not defined. So we didn't do much work with the graph on a log function, but I do want to take just a minute here and tell you that for any log equation, the domain runs from 0 to positive infinity, which means that you cannot take the log of a negative number. So I'm just going to write this down, and you might want to put it in your notes as well. So can't take log of a negative number. It will simply give you something that's undefined. So even though when I work my problem out, I get a positive and a negative 3, the only solution that's going to work is going to be the positive 3. Because when I put the 3 back in, if I were to put the negative 3 in for the x and then try to take the log of it, we would get an error. Our next example says log base 4 of x plus 3 plus log base 4 of 2 minus x is equal to 1. Again, this is not a good candidate for changing to exponential form because we have too many pieces. So instead, I'm going to try to do a property. I know that there's a property that deals with two logs that are added together. That property says that we can combine those two logs into one log with multiplication. So I could have log base 4 of x plus 3 times 2 minus x. And then I'll still set it equal to 1. Okay, so that's my property. Now, I'm going to kind of reassess at this point. I don't see any other properties that I can use. The properties would indicate that we had either an addition or multiplication in between two logs, which we don't, a division or a fraction, which I don't see either of those, or exponents, and I don't see any exponents. So I don't think that there's anything else I can do with the properties right now, but I can change the form to exponential at this point. So let me try that. So remember, start with your base, go to the other side of the problem and get the exponent, so that would be 4 to the first, and then set it equal to what's left. Okay, so let's do a little simplifying. 4 to the first is just 4. All right, I'm going to do FOIL method over here. So first times first is going to be 2x. And then my outside is going to be a minus x squared. Then my inside will be positive 6. And my last will be minus 3x. So I have 4 is equal to, I'm going to write these things in descending order. So I have a negative x squared. I'd have a positive 2x and a negative 3x. And then I have a positive 6. All right, now I'm thinking ahead and thinking that I'm going to be factoring. So if that's the case, I know that I really would like my x squared term to be positive. So I'm going to start moving things to the left. So I'm going to add this x squared to both sides. So now I have x squared plus 4 is equal to negative x plus 6. I'm going to add the x to both sides. So now I have x squared plus x plus 4 is equal to 6. And then finally I'm going to subtract off the 6. So I have x squared plus x minus 2 is equal to 0. Now my hope is that I'm going to be able to factor this quadratic equation. So x squared would have to be x and x. 2 would have to be 2 and 1. In order to get a positive x in the middle, I would need my larger term to be positive. And then we're going to set both of these equal to 0. So x plus 2 is equal to 0, and x minus 1 is equal to 0. And so when I solve, I'm going to come over here. When I solve, I get x is equal to negative 2, and I get x is equal to 1. Now, let's keep in mind what we just talked about with the negative values in terms of taking a log. Now, the tricky part is that just because the x value is negative doesn't mean that it automatically needs to be eliminated. You have to plug it back in. So let's look at the negative 2. If I put a negative 2 right here, I'm actually taking the log of positive 1 inside that parenthesis. Negative 2 plus 3 is positive 1. So that's fine. If I put a negative 2 right here, 2 minus negative 2 is positive 4. So that's also fine. All right, so this is definitely a valid solution, the negative 2. We should also check the 1 just to be sure. So if I put a 1 right here, I'm going to be taking the log of 4, which is fine. If I put a 1 right here, 2 minus 1 is still positive 1, so I should be okay there as well. So in this one, we have both negative 2 and positive 1 as valid solutions. All right, we're going to do one last example. So we have 2 log base 3 of x plus 4 minus log base 3 of 9 is equal to 2. Now, I see several opportunities here for properties. The first thing I notice is that I have this 2 sitting in the front. So I'm going to go ahead and move that up here as an exponent, and I'm just going to cross it out right here. All right, I also notice that I have a subtraction in between 2 logs. So I know that 2 logs can be combined with a subtraction by making a fraction out of it. So we'll have x plus 4 squared divided by 9 is equal to 2. All right, so now I'm down to 1 log. It would make sense at this point, since I've exhausted all my properties, that I go ahead and change it to exponential form. So we'll start with the base of 3. We'll go to the other side and get the exponent of 2. And we're going to set it equal to this fraction. All right, so let's do what simplifying we can very easily. 3 squared is going to be 9. All right, so the next thing I think I'm going to do is attempt to eliminate my fraction. So in order to get rid of my fraction, I would multiply both sides by 9. That would cause the 9's to cancel over here and leave me just x plus 4 squared. And 9 times 9 is 81. Now let's think about how we can solve this. We have a perfect square on both sides, so it might be easiest to take the square root of both sides of this expression. On the left, that would give me a positive or a negative 9. On the right, that would give me x plus 4. And then subtracting 4 from both sides would solve the expression for x. Now, I do have 2 options. So one option is that the 9 is positive. So positive 9 minus 4 is going to be positive 5. The other option is that that 9 was negative. Negative 9 and negative 4 makes negative 13. All right, so now let's go back to our problem, the original problem, and let's make sure that both of our answers work. So if I plug a 5 in right here, I'm going to be taking the log of 5 plus 4, the log of 9. That's going to be good. As long as it's positive, you're good. If I plug a negative 13 in for the x, that is where we're going to get a problem, because negative 13 plus 4 is negative 9, and I cannot take the log of a negative number. So I'm going to cross this one out. It is not a valid solution. The only solution to this particular problem is going to be 5.